Okay, so welcome back. Today we're going to talk about reciprocal functions and then a little bit cofunctions. Reciprocal functions first. Talked in class about the fact that there's actually 6 functions, not 3. And so what we want to do is set up the reasoning behind these reciprocal functions, or not even the reasoning, but the relationships, I guess. So if I take you back to the right triangle, we already looked at the relationships between the sine of A, the cos of A, and the tangent of A. Sine of A, of course, being opposite over hypotenuse. Cosine is adjacent over hypotenuse, and tangent is the opposite over the adjacent leg. It's very important that when you're setting these up that you have them in the appropriate order, and that the opposite is the numerator and the hypotenuse is the denominator for the sine ratio. However, what happens if we take the reciprocals? And that's what we're going to look at today. If I take, instead of opposite over hypotenuse, the hypotenuse over the opposite, I get a function that we call the cosecant of A. If instead of adjacent over hypotenuse, I take hypotenuse over adjacent, that becomes the secant of A. And of course, tangent, if I reciprocate opposite over adjacent and turn it into adjacent over opposite, it becomes the cotangent of A. So really, you're literally just reciprocating these ratios. Now, as far as the abbreviations go, we already know that sine, cos, and tan are the first 3 letters of its function name. Cotan, I can do the same thing. I can take the first 3 letters of cotangent and call it the cotan of A. Secant, no problem. SEC is the secant of A. But cosecant has a problem because COS here is already being used with cosine. So instead what we do is we take the first 3 consonants, C, S, C, and we will call it the cosecant of A. So here's an example, a really quick example, a 3, 4, 5 right triangle. And I want you to fill in, or we're going to fill in all of the ratios for the 6 functions. So sine of x, because it's opposite over adjacent, or opposite over hypotenuse, sorry, will be from x, the opposite is 3, the hypotenuse is 5. And so the sine of x would be 3/5. Cosine, because cosine is adjacent over hypotenuse, it's going to be 4/5. And so I would say that the cosine ratio is 4/5. And then tangent, opposite over adjacent, would be 3/4. Now the cosecant, secant, and cotangent are simply the reciprocals. So if I know that the sine ratio is 3/5, then cosecant is just going to be its reciprocal, which will be 5/3. So it's easier for me to remember that cosecant is reciprocal to sine than it is to remember that cosecant is hypotenuse over opposite. Okay, so again, cosecant and sine will have reciprocal ratios. Cosine is going to be reciprocal to secant, and so if cosine is 4/5, secant will be 5/4. And same with cotan and tan as reciprocal functions. Cotan would be 4/3 because tangent is 3/4. Okay. So I have an example here where I am giving you a sine ratio for a triangle in quadrant 1. What's nice about quadrant 1 is everything's positive, so don't have to worry about my signs here. If I tell you the sine ratio is 5/13, I'm going to ask you to find the other 5 trig ratios. So 5/13, I know that this is the opposite side, this is the hypotenuse. So I can put those 2 pieces into my triangle from x, that's the opposite, that's the hypotenuse. And of course, if I know my triplets, I know then that the missing piece is going to be 12. This is a 5, 12, 13 trig ratio. Okay, let me throw my little... Okay, now the other functions are very easy, because if I know that the sine is 5/13, you know what, I'm just going to set this up because this is the easiest way for me to do this so I know I don't forget one. Sine, cos, tan, and then the reciprocals are cosecant secant, and cotan. So sine was given at 5/13, which means cosecant is going to be 13/5. If cosine is adjacent over hypotenuse, we get 12/13. Secant's the reciprocal to that, 13/12. Tangent will be the opposite over the adjacent, 5/12. Cotan will be 12/5. So these are the identities you want to get into your notebook. The fact that the secant of x is equal to 1 over cosine, which will remind you it's reciprocal to cosine. Cosecant of x is equal to 1 over sine of x, which is reciprocal. So those are the reciprocal identities. And then tangent and cotangent we're going to think of as quotient identities. Tangent, we already talked about that. It's the ratio of sine over cos, which means cotan, as its reciprocal function, will be the ratio of cosine x over sine of x. Okay, so those are the four that I need you to get down into your notebooks and memorize. So here's another example. I'm telling you the cosecant of x is negative 5/4. I'm putting this into quadrant 3, so there's going to be a little bit more to think about now. First thing I'm going to suggest is that you draw the triangle and label the parts. Now here's the thing. Cosecant, I'm not real familiar with cosecant, but I do know that cosecant is reciprocal to sine. So what that tells me is if cosecant is negative 5/4, then the sine will be the reciprocal, which is negative 4/5. Now the fact that it's negative is because it's sitting here in quadrant 3. Okay, so if that's the case, then I know that the tangent is going to be positive and the cotangent is going to be positive. But all of the other four ratios will be negative. Because keep in mind, taking a reciprocal does not change the sign. So wherever sine is negative, so is its reciprocal cosecant. Wherever cosine is negative, so is its reciprocal secant. Wherever tangent is positive, so is cotangent. Okay, so I can now place my parts, if you will, here onto my triangle. I will call this angle x, and so sine will be opposite, hypotenuse, and then the missing piece is 3. Which means now that the cosine will be adjacent over hypotenuse, and of course I'm going to make it negative because I'm in quadrant 3, which means that the secant will be the negative of 5/3. Tangent will be opposite over adjacent. It is positive because I'm in quadrant 3. Remember, all students take calculus, which means then that the cotan, get rid of that. The cotan is going to be 3/4. Notice when I do it, I don't put 1 over because that's just going to create complexity. Think of 1 over as reciprocal of. So instead of saying that, secant is 1 over negative 3/5, that just creates a mess. Simply reciprocate. So let's say I ask you to find the exact value for, say, the secant of 240. We're not going to memorize a whole nother chart. What I'm going to understand is that the secant of 240 is going to be the reciprocal to the cosine of 240. So if I can figure out the cosine of 240, all I need to do is take the reciprocal of that. Still going to QRS this, okay? 240 is going to sit here in quadrant 3 with a reference angle of 60. It's going to be negative because sine or cosine and secant are both negative in quadrant 3. So the secant of 240 is going to be the same as the negative of the secant of 60. Or I can think of it as 1 over the negative of the cosine of 60, whichever way I want to think about this. Now, if I know that the cosine, or the negative cosine of 60 rather, is equal to negative 1/2, then what that means is that the negative secant of 60 is going to be the reciprocal to that. I'll just take it negative 2. I'm not going to put it over 1 because we don't want that fraction with a 1 in the denominator. Okay, so again, if you know the cosine of 240, you just simply take the reciprocal of it to find the secant of 240. QRS is still going to be part of this process. What's the quadrant? What's the reference angle? What's the sine? So now I have the cosecant of 120, and I want to find again the exact value ratio. Knowing that cosecant of 120 is the reciprocal to the sine of 120. So again, if I look at my QRS piece, I know that the reference angle is going to be 60. Okay. Now I know that the sine of 60 is equal to radical 3 over 2 from the work that we did the other day in our chart. It is positive because in quadrant 2 sine is positive, which means cosecant will also be positive. So if I know that the sine is 60, or the sine of 120 is radical 3 over 2, then I can tell you that the cosine, or the cosecant, sorry, of 120 will be the same as the cosecant of 60, same reference angle. And so I'm going to actually reciprocate the radical 3 over 2 and make it 2 over radical 3. Now, we know that we can't leave this radical in the denominator, so I'm going to rationalize this by multiplying by radical 3 over radical 3, and I will tell you then that my answer will be 2 radical 3 over 3, and that will be the ratio for the cosecant of 120. We are going to be practicing these in class. So again, what I need you to memorize right now is that secant goes with cosine, cosecant goes with sine, and then tangent and cotangent are reciprocals of each other. One way that you can remember that, the sine of x is the reciprocal to the cosecant of x, and then you've got the cosine of x is the reciprocal to the secant of x. And what you can realize is that one of the functions starts with s and the other one starts with c. But it's not cosine, it's not the cofunctions. So there's one that has a co and one that doesn't. Here I've got an s for secant, and then its reciprocal function is the cosine. So this is the one that has the co. One has a co and one does not. One starts with s, one starts with c. Sine, cosecant, secant, cosine. Okay, so they kind of switch partners there. So we want to talk about this idea of cofunctions. There are actually three sets of cofunctions: sine and cosine, secant and cosecant, tangent and cotangent. And the whole concept of a cofunction I'm going to show you with sine and cosine. It's the easiest one for me to show you with. And I'm going to show you with the 3, 4, 5 triangle again because that's such a nice little triangle to work with. So given angle A and angle B, what I can tell you is that the sine of angle A is equal to 3 over 5, opposite over hypotenuse. But the cosine of angle B is also equal to 3 over 5. Because if you think about what's happening, the side opposite angle A is going to be the side adjacent to angle B. They both compare to the hypotenuse. So the other thing that you need to realize is that because it's a right triangle, angle A and angle B will always be complementary. So the measure of angle A plus the measure of angle B, measure of angle B will always equal 90 degrees. And because they're complementary, what I can tell you is that anytime you take the sine of angle A, it will always be equal to the cosine of its complement, angle B. So here's a prime example, and we've actually already looked at this when we looked at our special angle ratios. I have my 30, 60, 90 triangle. My sides are 1 to 2 to radical 3. So I already know that the sine of 30 is 1/2. So is the cosine of 60 1/2. I could do the same thing with the sine of 60 at radical 3 over 2 is going to be equal to the cosine of 30 at radical 3 over 2. anytime you have complementary angles. So they must add up to 90. What that means is that it's going to be part of the same right triangle. You will always find this relationship. So what I can tell you is that the sine of any angle A will always be equal to the cosine of its complement, and we're going to write that 90 minus A. I can also tell you that the secant of angle A will be equal to the cosecant of its complement, 90 minus A. And just the same way, the tangent of A will be equal to the cotangent of 90 minus A. So as long as you have complementary angles, you will always get equivalent ratios. So one way that I could ask you this is to ask you, well, what's the cosine of 20 if I take the sine of x and the cosine of 20 are equal to each other? What does x have to be? X has to be 70 because they have to be complementary. So just a quick little thing about cofunction and the relationship between cofunctions. All right, so tomorrow we're going to be looking a lot more closely at the reciprocal functions.